Good afternoon, everyone. Thanks for having me here. My name is Zhong. I'm the CEO and the co-founder of ScaleFlux. As a big fan of ScaleFlux, what I enjoy doing is to maximize the benefit and the potential of flash memory for Aerospike. And today, I'm going to show you from different perspectives, how do we achieve that? Before I jump into that, can I do a little survey? I'm sure that when you are using Aerospike, you are using a lot of flash. How many of you are using more than 10 terabytes of flash? Quite a lot. And how many of you are using more than 100 terabytes of flash? Wow, still quite a few. I wouldn't be surprised that we are seeing more people are using over petabytes flash as well. As you know, flash probably is one of the most costly parts in your infrastructure. And for sure, we want to make good use of that, right? So today, I'm going to talk about another way to look at that. The way is called computational storage. Before I jump into that, a quick 1 minute introduction of the company. ScaleFlux is a company based in Silicon Valley, and we support customers worldwide. And ScaleFlux is the first company that introduced the computational storage into the market, and the product has been in the GA since mid of 2017. For the computational storage, let's see, what is the computational storage and why does it matter? As we know, the data-driven applications like database, big data, AI, or CDN, the few common things, one is there are more and more data. The data is going exponentially, and we need a much faster access to the data. And that's why in the market we are seeing more and more PCIe NVMe SSDs together with 3D NAND media, right? And on the other hand, when you have more data, you want to process or compute it much quicker, right? The response time is, has high demand. To solve this problem, the way our approach is solving the bottleneck at the storage side and computing side simultaneously, and that forms the idea of computational storage. It's actually not a new idea. It's just because of the flash and SSDs that are being widely available in the market, and also the Moore's law is slowing down, and now is the great time to have the computational storage in the industry. And this will give you a lot more faster response and also drive your infrastructure costs down, and also the agility to adapt to more applications. Okay? Through a simple comparison, you can see that why it makes sense. Today, most of the server or your infrastructure, server cluster, you are plugging a lot of SSDs, particularly NVMe SSDs in the server, and you have a lot more bandwidth on your data, right? However, your CPU and the DRAM are not improving as much. So this way, you will start seeing more bottleneck about the data movement from the storage, NVMe SSD storage to the DRAM and also to the CPU. The one way to solve that is to add another accelerator like FPGA or other ASIC accelerator in addition to the CPU. However, this doesn't solve the data movement. Right? You still need to move a lot of data from your flash storage and goes through the CPU subsystem, and you are going to still see the bottleneck between storage and your DRAM and computing and your processor. So if we slightly adjust that, it goes through another approach called data-driven instead of processor-driven. This can be much better balanced approach. The reason is, instead of put a big FPGA or ASIC accelerator side by side with the CPU. We distribute that into the storage device, or just like NVMe SSD device. And in that way, when you add in your storage, you are also balance your computing power. And also, it enables you to add in more functions in parallel with multiple FPGAs or other accelerators. This can maximize your parallelism in your server. As you know, the most available slots in your server is actually the PCIe slot, more than your CPU sockets, right? So this is how we balance the computing and the data storage bandwidth. Okay, so another very important thing is we didn't change any of the physical structure of your server, right? The computational storage device is plugging into the server just like commodity SSD. It's very easy to integrate. However, the performance is much higher. And you got the performance and also easy deployment with large capacity of storage. Talking about the performance, when you use Aerospike, one of the first important tasks you want to do is ACT, right? We know that ACT pretty much certified that your storage layer can live up to the expectation for your faster database. Sometimes we run into some issues with some customers when they are trying to set up Aerospike, and they see sometimes they see the long tail or not getting the right performance. And then when we try to work with them, and one thing that they realize that, okay, maybe we need to do some tests on the hardware. And then we work with them and run the ACT test, and I found out sometimes when they use a lot of SATA SSDs or other not so well performed NVMe PCIe SSDs, they see they are not passing ACT test at the certain performance level. So that's one of the major reasons that we want to run the ACT before we tune the software or database layer performance. As you can see here, the computational storage, we call it CSS, has the largest transaction per second compared with commodity SSDs. If you compare to on the second place, actually, this is SSD with 50% over provisioning, right? So that actually comes with a higher cost. And also, the third one is the one with higher capacity, with the same over provisioning, which is typically 28%. And you are comparing the same over provisioning and the capacity. The CSS, computational storage, has about 3 times more performance given the certain consistent latency. Okay, so in this way, if you look at your CapEx and OpEx, you get serving on both ends, because to achieve the same performance, you only need 1/3 of the device to get there. And of course, you are going to save, it's going to save you save your power, as well as your maintenance, especially reduce the number of potential failure points. So that's how the computational storage help us optimize your cost on the flash storage. To make things even easier, we certify that through Dell, server vendors like Dell, and you can just directly go through their program and get that ordered as well. And meanwhile, we're also working with other server vendors like Lenovo and Inspur to get that ready. Okay, so now let's see. This is a simple and an easy way to improve the efficiency of the flash deployment for your infrastructure, right? And can we do more, do better? One promising approach is actually, if we take one step further, look at the joint optimization between Aerospike and the device level, we found some really interesting approach. Okay. So the goal to do that joint optimization is when we want to do more transaction per second with more consistency, and meanwhile to achieve more lifetime with the flash, because everyone knows that the flash has limited lifetime, right? And also, meanwhile, reducing the cost. How we achieve that? One of the most common operation when you run enough workload on your database is defragmentation, right? Defragmentation is the operation that to reclaim the file system space when it's no longer needed, right? And then there's another similar operation at the storage device level called a garbage collection, which also doing similar things. What it does is to reclaim the physical storage blocks at NAND flash to make it usable for the new data when you are writing new data into the storage device. So they are essentially doing similar things, but they are not aware of each other. But both of them are consuming extra space. For defragmentation in the Aerospike, we usually need to reserve about 50% of space, right, for the defragmentation. And for the garbage collection at the SD level, you usually need to reserve about 28%. So both of them are consuming extra space, which also means more cost. What if we can combine them, jointly optimize to make them be aware of each other? When you are doing defragmentation, at the same time, you can tell the storage device, hey, I want to do the garbage collection together, so we can avoid do them separately, because it's going to increase your write amplification, your read amplification, and also slow things down. Right? If we can merge them and make them be aware of each other, that's significant saving. As a result, we can see if without the combination and running the garbage collection and defragmentation separately, you will see with reasonable over-provisioning, you get reasonable performance. It's relatively consistent, right? However, if you want to remove the redundancy at the device level, your performance is going to fall into a cliff, right? And it will drop significantly. With the joint defragmentation and the GC, the nice benefit is you are going to get a lot more smooth performance, much more consistent, and also slightly higher performance. That's really good, right? And it's give you more space, more storage, and better performance and consistency. That's the power when you make the database and the device working, joint working together optimally, right? Okay, when we do this, we can do a simple comparison. In terms of performance and predictability, the joint GC with computational storage are a lot better than the commodity NVMe SSDs. And also, as we mentioned, it's going to improve the endurance of your flash device as well, because you reduce the write amplification and the read amplification. And in this way, actually also improve the performance, meanwhile. And of course, it's going to also save the extra space that you reserved for the garbage collection and the defragmentation as well. So no compromise. What's more is, besides the baseline 3x performance and the joint group GC, what's more exciting down the path is we can add the inline compression, transparent compression, without changing any application level source code. And in this way, we can boost another 2 to 4 times saving on the storage, depending on the workload and the data pattern. Same thing we can do also inline encryption to further speed up the performance of your server. So those are things that you can get from computational storage that are not available in the commodity NVMe SSDs. So we are looking forward to working with Aerospike on getting those features into the market. Right? So in summary, the computational storage can achieve big gains through combining software and hardware innovation. And not only they can achieve higher performance, better consistency, but also endurance as well as the cost. And the deployment is very simple, just like using commodity SSDs. It's very simple, and no change on the servers. Also, there's more exciting features and the benefit coming down the path. So then the conclusion is pretty simple. Using Aerospike together with ScaleFlux, the more you use, the more you save. Thank you. Any questions?
Do you have any metrics posted on Aerospike website or your own website about the ACT test?
Yes, we have the ACT test on the Aerospike website. You can go to that page and check that out.
Okay.
Yeah.
What is the price point between the regular NVMe drives and ScaleFlux?
Okay, the price point between the computational storage and regular NVMe SSD, the answer is the cost structure is very similar. We are talking about 10 to 15% delta with 300% of the performance. So that's pretty significant. Yeah. I mean, in terms of performance, right? By only about 10 to 15% pricing difference, yeah, that's going to be quite efficient. Go ahead.
So how do you address the change from one NAND type to another? So let's say, like how do you maintain that performance?
How do you
Maintain the performance, let's say if you're using a Micron NAND flash against Toshiba or the next SCM maybe,
Okay. So the question is, how do we maintain the performance using different flash media, for example, either Micron or Toshiba device, right? So our current focus is on the 3D NAND. So if you compare the baseline of Micron or Toshiba or Hynix, they're actually pretty on par to each other. So what we need to do is, at the flash management level, we want to make sure that all of those media devices can perform consistently as expected. So those are absorbed in the flash management layer, which is called FTL in the product. Thank you. Okay. Any more? Okay.
You mentioned that you certified it with Dell R640. How about 940? And also, do you have drivers for like Windows platform?
Okay, so two questions. One is how about other server SKUs, right? We certify R640, and other server SKUs are able to will be available once we the request to the Dell. So it's about a 2-week cycle for each new SKU for Dell to certify that, because they already run all the baseline tests, and for each SKU, it's quite easy for them to rerun that. The second question is about the Windows, right? We are currently only support Linux, not Windows yet. Okay. Thank you. Thanks, Jim.